This is a follow-up to both my talk at Cauldron last year and my talk at LPC last year. Basically, I've got two goals: to let libctf in binutils serve as a deduplicator for BTF, so that the kernel can use it to deduplicate BTF if available. Hopefully, doing a good job and taking some load off Pahol. And to eliminate CTF as a format as far as possible, and turn it into something as much like BTF as we can, so that BTF class tools can use it. I think that we can at this point that we can almost completely replace CTF with BTF. Probably not completely. I can go into why. I've got a to-do list. The link is there. I'm working my way down it. What we've got at the moment is a proof of concept which can consume BTF from the kernel build process, deduplicate emitted by GCC, deduplicate it at multi-file module link time, and again when everything is linked together at the end, right before Pahol runs, and it then emits an archive containing deduplicated BTF for all the modules and the kernel, hopefully distributed in more or less the same way Pahol would do once it deduplicated, packaged in a form where Pahol could, in theory, read it and decorate it with any other things that it needed to do in order to get functioning kernel BTF out of it. It's very much, this archive is very much an intermediate representation. I don't really expect it to be used by the kernel in general, except to be consumed by Pahol, but it is the same format that gets used in user space to be linked into what are currently .ctf and will hopefully eventually be .btf sections. So I would like the archive format to be useful. We have this dedicated, currently that branch has a dedicated archive format which is rather overcomplicated and kind of tar-like. Alexei had a wonderful idea, well, Jose had a wonderful idea and Alexei simplified it into, why not just use straight concatenation? Just concatenate BTF files onto the end of each other. And then you can use the length field on each one to tell where to start reading the next one, and the magic number to tell whether this is actually BTF or not. I'm still working on it, but I think it will work really well. The upside is that this is what linkers emit even if they don't know how to deduplicate BTF. If you feed it to an unaware linker, you get a bunch of BTF sections to an unaware linker, you get a big BTF archive in this format out without needing to do anything. If you feed it to the one in binutils, you get a deduplicated one out where the first member is the parent of all the others and contains deduplicated content. There is a question there which I'll get to later. There are a few things I haven't done, mostly things I broke while working on this. We want to be able to read the older formats of CTF and dynamically convert them into the newer formats. Among other things, this is because GCC knows how to emit the older formats, and I'd like to be able to run the full test suite again. We had a skit there doing this, found some bugs in the deduplicator which I will fix. For example, sometimes GCC emits const volatile and sometimes it emits volatile const to optimize the number of dwarf nodes. And we would like to canonicalize the order of these so we can always scrunch them together rather than having lots of const volatile and volatile const pointing to the same type. The API is overcomplicated and has too many bits in it. It needs simplifying. I have an ongoing API review, which I would be happy if people contributed to. Send email if you think of a way to make the API simpler without losing half of what it can do. I've partially tied all of this into the kernel build process. I haven't connected up to Pahol mostly because I thought Alan was going to do it, but he's been doing other things, and I don't think it will be too hard to connect up to Pahol. I have an example of a skeleton which can do the work if only I knew where to put it in Pahol, and it's only about 20 lines long. For my configs, it's pretty fast. The worst case I've ever been able to produce is 17 minutes and using about 16 gig of RAM, and that's make all yes config and make all mod config, which are crazy configurations which you only use if you're testing. We're going to this is only single threaded. We're going to multi-thread it. It will speed up. I think Bruce has a patch for that. There are a few things that came up. So my end goal here is to eliminate CTF as much as possible. At this point, the only difference between CTF and BTF, between CTF-v4 and BTF, is that CTF-v4 has a few extra type kinds in it. Most of them, I just picked them off the end of the list. I just picked them off the end of the list, which is an appalling kludge. It has a different magic number, so you can't mix the two up. The extra type kinds, one of them is for conflicted types and will only be used in the intermediate kernel representation, so we can ignore it. One of them is for gigantic structures. If you've got a structure which is has 100 million members in it, and there happens to be a gap in the middle, a padding gap in the middle of the structure, which is 500, which is 100 megabytes long, BTF cannot represent that because its VLAN isn't big enough, and so on. And I can't imagine it will ever want to, because this would be an insane thing to have in the kernel. So there is a different representation for gigantic structures in CTF. This is only used, and we only switch to generating CTF rather than BTF if we need to. And you can tell the API, if you find one of these, error out. If you find one of these, replace it with unknown and just omit BTF anyway. There are some user space programs that have such gigantic structures in. There are a few other cases where we currently generate CTF, but I would like to stop to eliminate all of them by agreeing on ways to represent them in BTF as well. Here they are. The first is that if you've got an archive full of different bits of BTF, when the CTF deduplicator runs over things, each of these archives represents, except for the first, represents types which came from a single translation unit and conflict with, maybe they've got the same name as but different definitions, types in other translation units. So I'd like these entries to be named so you can tell which translation units they corresponded to. Doing this would give us another advantage, which is that you could, if they were always used by things generating BTF, say every BTF generator filled this out with the translation unit it came from, you could tell if the linker that ran over them could do BTF deduplication by looking at the first member and saying, if it had no name, this did not correspond to any specific translation unit, it must be the result of deduplication. This is a deduplicating linker output, rather than something you'd need to deduplicate yourself in some way once you read it in. The alternative approach would be to assign a header field and just never fill it out, in which case you could also use this to distinguish between a deduplicating linker and a non-deduplicating linker, because the deduplicating linker will always fill out all of the entries except for the one in the first archive. But we do need that entry. At the moment, if we fill out that field, at the moment if we create an archive, we declare that everything in it is CTF and not BTF entirely because we have to put that blasted header field in, and that header field is not in BTF. This is ridiculous. Go through all this effort to make it BTF compatible, and one header field forces us to say it's still CTF. Other things, I'm sure CTF v4 has a few extra things in its headers for things like tables mapping ELF symbols to their types. I want to move them out. If I move them out and make them refer to move them out into other ELF sections and make them refer to, for example, the 43rd type in the third archive member, then BTF and CTF would end up with the same sections with the same header format, and another difference between CTF and BTF would evaporate. But for that, we kind of need to agree on a way to refer to this type in this archive. I think Alexei had a suggestion of just the number from the start of 64 bits, 32 bits of an archive member number, 32 bits of type ID. If we agree on that, then I can do that bit. Another thing is BTF doesn't bother with compression at the moment because it's normally put in modules on the kernel which are compressed as a whole anyway. In user space, the ELF loader doesn't really like decompressing. We have to have a decompressed binary with a compressed section in it. I propose just calling that section .zbtf, and so then BTF things that find that section know they have to decompress it and they get BTF out. Does that seem reasonable? The same sort of thing as is used for the rest of Dwarf? Does anyone disagree with .zbtf?
No, I agree.
Okay. Because that then means I could just omit those and eventually libbpf could learn how to read them. The only other thing that CTF is likely to omit in user space that BTF can't represent is floats. There is a BTF kind float, it's useless. All it's got is a size. This is because the kernel doesn't care. It might be nice to have something which at least indicates the number of bits of mantissa and the number of bits of exponent. I think that's probably all we need. I was talking to Ali Barami, who's the guy in Solaris doing CTF stuff, and he said that's all that consumers ever care about. How many bits have they got? We don't care about things like where's the imaginary part. We just care how big is the mantissa, how big is the exponent, then we can read this type and there's no problem at all. If we could just add that to the BTF kind float or add a new kind with or something like that, then the last thing that needs CTF rather than BTF would disappear, and we would only need to emit CTF rather than BTF for gigantic structures, which I don't think we would ever want to represent in BTF. I mean, unless you think the kernel is likely to include a 2 gigabyte long structure at some point in the near future. If we had those things in there, then we could have GCC and the linker deduplicating BTF across the entirety of user space without much difficulty. I have some kind of size info from compressed CTF, which would be at the same order of magnitude. The whole of Emacs, for example, produces about 200K of CTF I think that was before compression. After compression, about 70K. So it's pretty trim, given that Emacs is several tens of megabytes of code. I do have possible improvements in the future to deal with crazy pathological cases. GhostScript is a nice one. GhostScript has this object-oriented C scheme with gigantic structures which are almost the same as each other, but with the same name in almost every translation unit, which leads to it having tens of megabytes of type information. I have a possible new type kind which could let you say, this structure is like this other structure over here, but with these changes to it, a delta. But we can deal with that later. That's an edge case, and it doesn't mean major changes to anything at all. With these changes, if we could figure out some kind of agreement with BTF, we'd have BTF deduplication in the kernel from the toolchain, with Pahol not needing to do it, except if Clang got involved. And we would have the same thing in user space, and the BTF in question would still be readable by all BTF tools, and it would be the same BTF that is emitted for BPF programs, which I think is a nice combination. Two competing type formats would reduce to one. That's whether people agree to this radical set of changes, I don't know. I couldn't think of a way to get them any simpler. There are a few other improvements I've got planned. There's something for libabigail, which can let it rapidly determine whether two types are different. But again, we can stick those in different else sections, which makes them formally not part of BTF, so I don't need to bother people with them. The whole bag on the side of BTF approach works very well. Do people think this is doable? A single string header? Single string in the header with a name?
Well, first of all, I personally don't see them competing. Like, keep CTF. There is no need to do any of it. Like, BTF never meant to be...
They're so similar.
To describe user space. That's why it's like really kernel specific. For things existing in kernel, it's being practical. And for CTF, you want to compile user space, go ahead, like do whatever. Like BTF, it's not a job for BTF to represent user space. So that's all. But there are... No.
But as of that, right, BTF is... There is no need for BTF to cover user land, user space, I agree. However, if BTF is to be supported by toolchains, like GCC and the GNU Toolchain in particular, then it needs to reach some maturity level in the sense that for example, in BPF, we know that you don't link objects externally using external linkers yet. However, the BTF section at the moment, for example, is using procbits type for the section. So every linker in the world that finds a BTF section will assume that it is fine to link it by concatenating it. So at the moment, if you concatenate to BTF sections, you get nonsense, right? I mean, well, it's not exactly nonsense, but undefined behavior, so to say, right? I mean, because it's not intended to that. So in a way, even if the object of BTF is the kernel, as long as it is supported by general purpose toolchains, it has to pay some attention to those things.
Well, the nice thing is it turns out almost no changes are needed, which is...
Well...
like what you're describing makes sense. What I'm saying, all of user space does not. There is a difference, right?
Yeah.
For example, like floating point type. As soon as we say floating point, well, there are vector types. And also
No, that's
let's
a
represent them.
vector type. We got
Vector
that.
types exist in the kernel.
Vector types are arrays. Vector types are arrays.
As to
It's
that,
easy.
I have no objection. To that, I have
Yeah.
no objection, but to the other, yes.
Well, right.
Vector types are arrays. They've already been handled. There are vector types in the kernel. Not many, but they're there.
That's why we're just saying, well, it's this size. That's it. We don't care because the kernel doesn't.
Okay, so maybe we can focus on the subset of this that actually, like, I am particularly interested in the linking. Like in getting BTF, to make sure that the BTF sections
That's how we phrase it.
are good citizens
just
in
know
the...
what linker point is.
Right,
And then,
right.
like, if it's a linker, and linker today, knowing nothing will just concatenate, what's wrong with that?
No, there is no wrong. It's the proper thing to do when you are a proc type section. But then you need to come to some agreement on how to express either different compilation units or the duplicated BTF by concatenating different
How
BTF
can you
sections.
tell what these concatenated
That's
bits
what Nick is
correspond
working
to?
on.
Yeah.
Yeah.
Yeah, but
If you've got 5 concatenated BTFs, they're all indistinguishable from each other unless you give them a name.
you don't need to. Like, why do you care what it came from? It's types.
Well, among other things, in the kernel, where there are a great many conflicting types, I know because I ran into this problem. The children correspond to kernel modules, and in that case, you do care which kernel module a distinct type came from.
But kernel module and linker, again, two different problems.
Well, we are literally using the same. It so happens we're using the exact same code. We're using the same code for it. So I would quite like to be able to not add pointless bags on the side when a single header field will solve all our problems in one go. It's not like it needs to be filled with anything by default. You can just leave it blank. It's 4 bytes, 40 bytes.
Nick, but at the moment though, BTF, CTF nor BTF can represent C++, right? My point
I
is,
suspect that it would only ever represent C++ and Rust by representing the C-compatible ABI part of it.
yeah, but what I'm saying is, if we
Then
were
it could
ever,
be
and
madness.
I would love a smaller debug format that we could always ship, though for other distros it's maybe not so relevant because of debugging FOD and stuff. But if we were going to build userland with it, we would build everything with it, and that includes a lot of C++, including GoScript, which is C++. So if CTF is already going to have to diverge from BTF anyway, I don't see how the two are really compatible at the moment. It's not just these things that would get it over the line to build user space, because first the C++ problem, and then all the other types. There's more than just this, is what I'm saying.
Well, this is all I'm aware of at the moment. On the C++ side, we might want, we might need new type kinds, but that's it.
Yeah, okay.
But even there, what for C++, what we'd be interested in is the ABI compatibility side of things more than anything else. We're less interested in the fact that this is a vector this is a type which came from this template and was on these source lines, and they'd use this crazy name resolution lookup mechanism, and more that this is its mangled name and
Why?
it's compatible with this C-like type sort of thing.
Right, but what do you want CTF to be used for?
Fundamentally, its primary goal at the moment is ABI compatibility-like
Okay,
things,
right,
which is
okay.
very similar to BTF again. It's large parts of it, the things like compile once, one everywhere. It's basically an ABI compatibility
If it's
problem.
purely for things like libabigail, then I can understand more. I thought you meant like for use in sort of very weak debugging where you want like debugging.
It's visibility into the type system,
Okay.
largely for the purposes of ABI compatibility, but not entirely. I'm not going
that
to
makes sense.
say that I know what purposes. Dtrace doesn't use it for ABI compatibility.
Yeah.
Dtrace uses it for visibility into kernel types. It's another possible valid use for it. That was the original use.
Okay, I don't know. I think
Yeah.
we are going
I think
a
it's
little
a
bit
big
off
question,
topic
yeah.
here.
Yeah.
Like, I mean, CTF by itself is not related to BPF. But that's why I say it is okay. So for the linking of BTF sections on the kernel side, not of BPF, the BTF generated by BPF programs, but for this idea about having the compiler to generate the BTF sections in the objects, and then to get the linker linking them. And by the way, I mean, I also agree that let's focus on that normal case. VM Linux and modules is its own thing, right? And probably it will need its own linker or its own stuff. So I think we all agree that we should concatenate for linking.
Yeah.
Actually, it's too late now to change it because you will need to change the type of the section. And I don't think that...
You might want to deduct while you're concatenating, but yes, I agree.
So would you accept like a proposal like just for that? Okay, first question, would you prefer the duplication or you would prefer like Dorf dash that is, okay, those are the types of input compilation unit foo.c or pal.c or the duplication because we have a duplicator, a BTF duplicator in the linker already. Which is worse, right?
And it works and it provides valid input to PAHL, which is, as far as I can tell, pretty similar to what PAHL produces from its own deduplicator. So,
right. So,
and if it's not, I can fix it so it is.
Currently, there is no need. That's what I'm saying.
well,
PAHL does dedupe across all multiple thousand different compilation using across the kernel. All of them are individual BTF sections. Dedupe them all. Put them in VM Linux.
I understand, but look, no, you don't care, but we do care. Look, at the moment, GCC can generate BTF not only for the BPF target.
Sure.
Okay, so I think Clank it limits it only for the BPF target. Okay,
Yes.
so as things stand, strictly speaking, I should remove the capability of GCC to generate BTF for other targets than BPF because I cannot generate at the back format that goes in a block bit section that you cannot get anything meaningful by concatenating them.
Why it's not meaningful?
Because
it doesn't have a name, it doesn't have to be there to be meaningful. That's
because there is no origin specification in the BTF section where there is no notion of compilation unit there. So when you concatenate several BTF, is
because
that okay?
it doesn't need to be.
Well, where did these types come from?
Okay, so it doesn't need to be in general.
Yes.
Not just for the kernel.
So it doesn't matter if types are just floating there, which are not associated with any compilation unit that they came from.
Why do you need to associate it? Only because you did it in the past.
Well, no. It's because
And Mark, you see
because the children of the BT in the kernel world are not just compilation units; they're modules. The parent-child relationship in the kernel is the kernel and lots of individual modules. You do want to know which module a type is in.
Are there actually, can you give me an example of a conflicting type name? Because these tend to be problematic for LTO anyways. We avoid them as much as we can. So what I'm saying is, can we just say, if you want to build this thing with BTF or CTF, you fix your types?
Well, at least one past kernel, structure inode was conflicting, which you must say was pretty significant type. You wouldn't want to lose. Well, now is a constantly changing point. But back when I was working on the deduplicator originally in the kernel 5.14 days or thereabouts, you had a single definition of struct inode which was valid across almost every kernel module except for 3, which had different definitions of struct inode. And what are you going to do about it if someone wants a struct inode? Which one do you give them? You probably don't want the one from those 3 compilation units unless you're doing something in those kernel modules.
Link time.
What, reject what at link time? Anything that uses struct inode?
You say, oh, I saw 2 definitions.
Well,
I'm going to bail out. We do that already for actual...
Well, that would give me a kernel, a deduplicator that refused to link the kernel.
But that's what I mean. You can just say, oh, well, fix the modules. If it's 3, I'm sure that we could work something out for those.
That was just one example. There are a bunch of others in which there are header files with ifdefs in them which edit members in and out of structures depending on which module they come from.
How does PAHL handle?
It doesn't. It just picks whichever one is the first one it sees and runs with it and hopes that the rest are the same, which is a bit worrying given that this stuff is relied on by the verifier.
Yeah, but does that actually come up though, where PAHL has picked the wrong type?
These are rare enough that it's.
Right,
I strongly suspect people hadn't run into them. They were mostly in the sound subsystem. Okay. But again, these things pop up now and then. You can't rely on people not adding conflicting types.
No,
because C doesn't care.
I understand, but what you're saying, what I'm saying is you're facing kernel side saying let's not overcomplicate BTF. It would be reasonable to say fix your types then and not worry about extending the format.
Well, the problem here is that as soon as you run into modules, most types in modules you want to be in the module rather than in the core kernel. That's what BTF's always done. we do want to say when we emit BTF that this BTF actually belongs to this module over here. We're going to do it with that field.
Yeah, but that's what we're saying. It's not clear why that's wanted, though.
Because at some point you want to be able to figure out which module you want to write the .btf section into.
Right. Okay.
Either we keep them permanently separated as separate file formats and simply prohibit ever writing into archive formats, or we have a dedicated archive format with a name at the front, or if we're straight concatenating and we have to put the name in the file format somewhere. There's no third option, there's no fourth option. Either we have a header with a name to value pair mapping or name to content mapping, or we have something with giving them names, or we can't figure out what module to put them in. I think that's it.
All right.
Yep.
So, okay. So what about type IDs when you concatenate?
I think that was your error in the first place.
Because the BPF types are like implicitly, they are referred by ID, and the ID is basically the position inside. So you will need at least some sort of convention if you have three BTF sections concatenated.
Which one did it come from?
In one.
Individual. So like imagine linker didn't concatenate them. They live as three separate files. Whether three separate files or one file and all of the sections together is the same thing. It doesn't matter how the files are called. You can rename the file.
No, yeah, but what you get when you link is like the concatenation of the contents of the three.
And every BTF section is valid in its own, right? It's self-contained.
Oh yes, yes.
It's self-contained, yeah.
Oh yes. The point being, if it's some other ELF section or something trying to refer to some type over here, you would generally want to say, I want to refer to the type in the second archive member, in the first archive member. You want a number on the front saying which one of these concatenated things you're interested in, because it's not just one thing anymore. It's a string of them. Would sticking a number on the front be reasonable? Apparently, the kernel already does this internally.
Okay. So maybe we should continue the discussion maybe in the mailing list or hallway or on details, but I think that's
it for me.
Maybe we advance a little bit. Okay, so I really need, it's okay if I disconnect here?
Yeah.
Okay.
Unplug.
I don't want anything to explode.
Almost certain nothing bad will happen.
So I need, because this is the BPF BoF, so I need 5 minutes, and for real only 5 minutes, to give a very quick status on the port. As of today, I don't know.
No, sir.
Oh, wait. Yeah. No, I don't know what you did. Okay, don't move. All right. So to give a little update of the port where we are standing today, and then after that we can get into the monitor stuff, which is the verifiable thing. And I believe that Alexei and the BPF people, they have ideas about this, and they can tell us how LLVM does this to begin with. And then I don't know if Krista is here. Oh, I invite him to come. Very nice. Because I see this SMT-GCC, and I was like, wow, maybe this is something that we can use for this. Okay, but first, only 5 minutes, the update on the port. Okay, so the goal of the BPF port in GCC, and in the GNU Toolchain in general, is to, at some point, become the primary BPF compiler. So this is a new goal. Up to now, the goal was like to be able to compile BPF programs in a way that they worked. But now we became more ambitious. Now we want to be the primary BPF compiler, not the secondary or third one. Okay. So what is the current status? Okay, so we have the BTF tags support that we know that the kernel is waiting anxiously for. Yeah, well, it takes time. So, Faust, do you want to? 1 minute. Yeah, that's.
I guess the only real update here is that the dwarf portions and the BTF and CTF portions are approved. So those are pretty much finalized in terms of like the implementation and things. The only reason the patch series hasn't been pushed yet is just the C front-end attribute handlers. There were a couple of issues that the maintainers wanted addressed, so I'm iterating on it. I sent the latest version right before I flew here.
Right. And Joseph, I think, is here in Cowdon this year. So maybe we can actually close the deal.
Can I show a few slides to explain at least this one?
Sure.
Why we care?
Sure.
Okay, we'll be just one for now. First of all, yeah, please do it. Obviously, this is, and not just for BPF, but it will for at least 3 backends. And the difference of like landing in for 3, there will be some minor stuff, but the whole, the front end pieces and middle end, like, will be obviously the same. This is really like #1 issue that prevents adoption of GCC BPF. Like half of the self-tests are failing because this is missing. And why we absolutely need it, and why we mainly were begging you, and screaming at you and yelling at you, do it now, because we need it for x86 and ARM64. This is not a BPF issue. Like somehow, I think people still somehow think that we need it for BPF. We need it for the kernel, for it to emit tags for GCC, for x86 and ARM and other architectures. Why? Like Clang added support for this like years ago. So this is like a simple example. In the kernel, half of the pointers, they are annotated with this _RCU or per CPU or user. There are a few other annotations, but these are like 3 main ones. Like whole kernel subsystem, whole kernel is pretty much pointers, and this like extra address spaces like. Per CPU now, as of half a year or maybe a year ago, actually a proper address space. It's like JS address space that like separate compiler treats it differently. But what we also do for the Clang side, that we also annotate this pointers with this BTF type tag and just a string. And what it gives us, this pointer annotation goes through the dwarf. Like there is no, like when Clang emits x86 code, there is no BTF. It just emits this tag into dwarf. Pahol takes it from dwarf, put it in VM Linux BTF, and the whole thing, like kernel, when it boots, it sees its own VM Linux BTF, it trusts it, and the verifier understands what these pointers are about. When it knows that the pointer is RCU, it does all the RCU appropriate checks when it verifying now like BPF programs, when the program is now accessing the kernel. When it says like user _user, it knows this is a user point, you only can use it like in certain cases. Like none of this is happening when the kernel is compiled with GCC. So in that sense, we, in the BPF verifier, we're like, we couldn't verify it, like it's probably okay. We don't know whether it's a real pointer or not, because like kernel couldn't tell us, because GCC didn't convey this information all the way from the build through the dwarf, through the Pahol to VM Linux BTF. So that's one example. Then we have like all sorts of hack on the BPF side, like in not only, like in this case, like it's some of the ugliness, it's sort of boundary line between like trace points and the BPF side. What we're doing now, because there is no type information, we put in sort of this extra suffix into the name. And because task _, so we have this convention, name added this __ suffix, and the suffix is special because name goes to dwarf, goes to BTF, goes to VM Linux BTF. In the verifier, we check, is there a suffix of this name? And then do all the crazy stuff. Like sometimes it's okay, but you obviously like 2 suffixes now becomes like really unreadable and long, and you don't want to use this kind of variable in your code. It will just like scream at you. So the first thing you can do is just rename it into other variable, and sometimes it's okay, except trace points. When the functions are generated by the macros, like whole of the trace points are, you cannot do it. So, well, for trace points, we have this super ugly hack. We first like wrote this Clang-based tool to analyze call sites and call lists of all the trace points in the kernel, and we're generating this stupid table of like name plus a mask, and mask here is a nibble mask of the argument that can be nullable. So the workaround, what we really want, instead of like concatenating and making suffix-based as a name, because for trace points this just doesn't work, to just tag it here, just change one line and say this is nullable. There is attribute nullable, like proper attribute nullable that's supported by GC Clang, but it doesn't propagate into the type system, doesn't go into the dwarf. So that's not really an option. The decal tags, the type tags solve it like nicely and cleanly. Again, this is not like really like BPF specific. We have other things, again, because there are no types, we modify the structure name. So effectively we define task struct. Task struct is like a main data structure in the kernel. We define it twice, once as a proper in the scat.h file, and then the second time we define a task struct, but we also add this __ save RCU suffix to a name. Name is now different, and within it we now know these fields. These fields are safe to access by the RCU trusses, like safety aspects. So it will be much better if like within like one place in the kernel where task struct is defined, like scat.h, we just add the suffix, which will be like a type tag. And the last example, we add like special flag also only because we don't have types. We say that, well, argument, and we have multiple flags for several argument 1, argument 2, like positionally where this arena pointers can be. And because at the end we need to generate this type of stuff when we emit vmlinux.h from the BTF. But again, like this is like super ugly hack, not pretty, only because again we're missing type and decal tags in GCC for x86.
Yeah, it's bad.
So yeah, I hope my please do it. Yesterday is clear.
Okay. Yeah. Okay, we've been working, this is the 10th version of the patch series. We had to rework the design of the dwarf site twice. We have to agree it with you. We agreed between the BPF people and us and the BPF backend people, like I think 2 times 2. We have worked over several conferences and now we need 2 patches of the series.
I think the author date in the patches is last February.
Right. So if we can get the okay from Joseph today or tomorrow, then we can get it in GCC finally. So, but yeah, it's bad. Yeah, we sympathize. It's bad. Thank you for making us to see how bad it is. We knew it already, but this helps. Okay, so the BTF tags, it will be going now, so no issue. So then we have the verifiable code test suite now in GCC, which is the demo that Thomas shown in the previous session, which is quite nice. And you saw the demo already. This is important for us. Okay, BTF, I'm gonna skip over it. And then we still have some issues and some bugs here which are open in compiler that there is nothing big, you know, or that very traumatic, but we need to get to those things. In the assembler, we still have to support the make goto, and also there are some optional BPF features that we are not supporting that are sort of accumulating there. So we have to take a look at those things too. Well, I'm gonna go over the ABI. Also the indirect jumps, which I see now they are on the works. We rely on the moment on Clang, generating some dedicated section with the CFG in it. And that's something that would be good if we could get GCC and Clang to agree on a format or something. Because, yeah. And then we have a verification issue. Andrew Pinsky, that I don't know if he's here or if not here, he wrote a patch like weeks ago for a problem in the verifier, which is GCC generates a shift to the right 32 bits. It's one of those cases that the verifier doesn't the value tracking doesn't cover. It's nothing.
Trivial, it's just that.
Yeah, but so I told Andrew, I will take your patch and send it to BPF, but I never did because, yeah. And that brings me to a little comment here, which is that we need help with the port. I mean, the people who are working on the port, which is me, is Faust, is Cooper, on work, we don't work on this 100%. So it will be nice, I mean, we will welcome any help. And if there is interest in the BPF kernel community in GCC becoming maybe at some day the primary BPF compiler, we would really appreciate if we, some help, like person power, hacking power, to tackle all those things, because it's difficult to follow because BPF is extremely active and there is a continuous stream of new stuff, like the maybe Goto, like now those CFG stuff that you have to emit for, and so on. So yeah, that would be nice. So the development continues, and yeah, you will have the tag soon. Okay.
Like in terms of manpower, completely on board. The only thing is chicken and egg. Like we're looking at how type tags taking years, and
okay, but I understand, but you got a big fat egg here, because we've been working on the egg for like how long now? And trust me, it's been not very fun work to crawl behind Clang, and try to figure out how everything works. Anyway, let the past be past, let's focus on the future. Yes?
Yeah, let's hope it's behind us and we can start moving fast. And when it's moving fast, then
yes,
we get all the help.
And that will actually also motivate us, to work on this, because, yeah, okay, good.
Like, for example, why we're hacking LLVM mainly? Because, well, we can just run stuff quickly, iterate on it quickly.
Yeah, but I like to think that one of the advantages that GCC provides is precisely that the GCC community is, sometimes it's strict in areas where you should be strict. Like, for example, thanks to Joseph not being, like attentive and not lenient, not lenient at all. For example, we found that one of the what is the declaration tag? There was a problem with the declaration tag at the function types, right?
It's type tag applied to the return type of function declaration.
Right. That doesn't make much sense.
Syntax sometimes it slides around and doesn't go where you expect. So that was something that was happening.
Which is fine, but because we agreed with Joseph agreed that it's fine. Now we are going to emit an error if that is found. Now that's something that you want to know when you add new attributes to the. So that's why it takes some time, but the quality is going to be excellent. So, right?
How many fingers do you need to cross?
I don't know, all of them. Okay. Yeah. Good. Okay, so actually, I think the first time we talked about this was a few years ago in one of the Plumber, LSFMM, I remember.
I told you, like Edward has slides on this.
Yes. So, well, basically the idea is to get the compiler to say, okay, optimize for verifiability, meaning that try to not break the verifiability of the code as you apply optimizations. And that basically could prevent legit optimizations from a semantic point of view. So similar to OSMAL or FAST, to have some sort of verifiable, so you can actually get compile time errors like, oh, this program is not verifiable in BPF, instead of having to go to the final stage, which is to load the program in the kernel. That's the idea. So now we were wondering, what is LLVM doing about this? Yeah. So we can do better. Yeah.
Well, actually, like, as a compiler, it's an ambitious goal for the compiler to tell that the program is not
very ambitious, yes.
Slightly less ambitious scope is just prevent it from changing the scope of the original structure of the original program.
Well, you tell us. I mean, you are the ones who with experience in this.
I will tell you about our experience. You won't like it.
Abandon hope.
Thank you. Okay, so optimizing compilers optimize, and they do this by transforming the code. And BPF verifier is a somewhat fragile thing. Like some of the transformations done by like valid semantically transformations can confuse it. So the program, if it was compiled as it was written, can be verified, but like after optimization, it cannot be verified. And over like the years, the backend, LLVM BPF backend accumulated a number of rewrites which effectively block some optimizations from being applied. And I just list examples of such transformations. And like a few words about the BPF verifier itself, like what it does. It simulates execution of the program, like instruction by instruction, keeping the state of the registers and stack slots. And for stack slots, like we are lucky because stack is limited. For one stack frame, we have 112 bytes, and we can only have like up to 8 stack slots. So, stack frames. So yeah, it tracks register states, stack frame state, and whenever it gets to the jump point, it forks the state. It continues like with the false branch and remembers to execute the true branch, like simulates the true branch. It can, like, to track the values, it uses two domains, interval domain and known bits domain. And it can track like simple linear relations between registers. And registers, I mean like register which is a register or register which is currently a stack spill. And this, like, if you have two constants added to the registers and those registers will link it somehow, like in this example on instruction number 1, we have R0 assigned to R1. And at this point, verifier assigns like the same ID to track that these registers represent the same value. Then the constant is added to R1, and it knows that R1 is actually like R0 plus 5. But this relation is easily broken. At the moment, verifier only tracks it for addition and jumps. So on jump, if it can infer like additional range for, like here, for this jump tells it on the false branch and on the true branch, the new range that R0 takes, and it propagates this range to R1 because of the link. If some other operations are performed on R0 or R1, this link is broken. And as it turns out, it's a problem for like kinds of optimizations Slang applies. So I will show like 4 examples of this. And first example is like when the address of a memory load instruction is hoisted above the range check for the offset which is added to the pointer. So suppose you have a pointer packet and some offset which you validate and then add it to the packet pointer. And it's perfectly fine in C to first compute the pointer and then access it after checking the offset. But
that's actually invalid C as well. However, it's not invalid for optimists to do it after the C has been produced.
You can't form an invalid point.
You can only point one entry past the end. But the optimizer is perfectly allowed to do that, to valid C after it's been written.
Well, it happens at the ER level. So I'm not putting like pieces of ER just for illustration purposes.
Yeah.
So yeah. And the problem here is that because we don't track relation between pointer and the offset after the offset was added to the pointer, this check doesn't tell verifier anything about the range of pointer. So if so basically at verifier side, we get this an unbound pointer at this position, and after this access, like we get a verification error. Yeah, well, original program can be verified because we know that if we enter the true branch of this conditional, we know the range of the off, and we generate the pointer with a limited range. So, and the workaround for this is just to match a pattern. If we have a value which is checked against some constant, and later it is used to compute an address, we insert like a call to intrinsic function. And this intrinsic function is basically identity, but the optimizer doesn't know it. So, and it is removed just before the machine code generation. Yeah, the next pattern is just, there is a path in the LLVM which is named like inst combine. It's just large number of peephole optimizations, just small collection of patterns to match and to rewrite. And one of those patterns happens to be this conversion for the OR relation. Yeah, and for verifier, it basically breaks the code again. So, well, like for the original program, if verifier follows the like false branch of this conditional, it knows that v is greater or equal than 1. Then it follows the false branch of the second conditional, and it knows that it is also less than or equal than 7. And then it can access memory at a certain offset. But here, because of this +8, it happens on the 32-bit subregister. And this is like the code is generated for 32-bit subregister because in the original C code, the variables are int. We lose the link. We don't track this linear relation anymore. So like this check doesn't tell us verifier anything. And hack here again, just to match the pattern and insert this intrinsic call, which masks, like basically blocks the pattern, prevents inst combine from matching the thing. Like another pattern, if you compare something with a power of 2 constant, it is replaced with an AND operator. And again, it breaks verifier because at the AND operator, the link between the registers is like we access in memory using register R1, but to compute this condition, we put it in another register, like R3 in this example. And after this AND operation on the instruction number 9, we lose connection between R3 and R1. And this check tells us nothing from the verifier perspective. And again, solution here is to mask this. If we match this pattern, exactly this pattern, like comparison with power of 2 constant, then we just replace it with intrinsic and like transform this intrinsic back to valid operation, like very late in the pipeline. Next, attribute preserve static offset. So in verifiers, there is a context of there is a concept of context types, and context is an like input parameter for the program. And historically, this input parameter, like it has a C representation, but it is not true physical representation of the type. When verifier processes the program, it remembers the places where like context is accessed, and after verification is done, it does post-processing on the program. It matches load and store instructions with static offsets and replaces these loads and stores with correct access patterns. And these access patterns can be like really like complex. Like for example, here, this CTX readval access. From the BPF program of view, it's just an access at the offset 36 from a certain like pointer. But physically, when the program is like post-processed by verifier, it is an access through several layers of pointers to a certain value. And this pattern, it works only on static offsets. It needs these load and store instructions to be encoded as instructions with static offsets. But compiler is allowed to move like address compilation where it wants, whenever it wants. Like, and there were examples, like in practice, when code looking like, for example, like this. The call to function bar was synced after the switch statement. Yeah, and the address calculation remained in the switch statement. So, and because of this, this program cannot be verified because, yeah, this is not a load with static offset. The offset for this load is computed. Yeah, and solution here is that we have an attribute which is named preserve static offset. And very early in the optimization pipeline, we just match access to the field, like through the pointers, like annotated with this type. We match and replace them with intrinsic, which combines address computation and context access. Store load, sorry, address computation and store load instruction. And those are workarounds which we have like on the compiler side, but there is like a ton of workarounds which are still user visible. Like in the test suite, like we have a bunch of variables declared as volatile just for optimizer, not to touch them, not to assume like value. And we also have like a few instances where we use this hack asm volatile just to hide the variable value from the optimizer. Yeah, I did not review like exact case study, well, which patterns require this volatile or asm volatile hacks. And yeah, as you can see, like so far we were being like reactive whenever some like reasonable program does not verify. We try to came up with a change to the LLVM backend. And yeah, wait till the next pattern. So what strategy do you plan for GCC backends?
Well, at the moment, we have no strategy because we just generate, I mean, we just let GCC optimize normally and whatever we get is whatever gets used. And
that's also the thing with the bug that was the SSH file thing. We have some things.
And we are already
to tell the compiler not to do this particular optimization.
finding problems.
We have this option too, backend specific check within the optimizers.
No,
It can be done with hooks.
actually that's our plan. I mean, what we think is that there are different approaches, and I think that in practice it's going to be to combine them. Like, but and minus O verifiable is something that we want to introduce because it's going to be the only way to convince the middle-end maintainers and the other maintainers to actually, like for example, so they will accept patches that is, if we are building with -O verifiable, then abstain to do this or abstain to do that.
So it's like a global fact, like O size versus and O fast or whatever.
Exactly.
Mass, something.
That's the idea. And we introduced this concept in a Cauldron, I think it was in Cambridge, like 2 years ago. And it was received with a mix of indifference and acceptance, but not particularly violent rejection. So
LLVM actually disables some optimizations for sanitizers because sanitizers don't work if it optimizes too much. So
that's interesting.
Like normal looking optimizations, they disable if sanitizer is on, don't do them. And we were trying to argue, like, look, we kind of need the same, but for this backend, can we just like next to sanitizer say like, if this is like for BPF backend disabled, and they're like, no, this is normal transformation. But they're like, you are disabling
right.
sanitizers, and they're like, no, it's like
well, so yeah, so
C virtual machine allows it. Yeah, but
so we think we need this general flag, general thing, so they know that we are not like improvising. Because if you send a patch to some optimization pass and saying, you know, I pass you an arbitrary flag and then you don't apply this perfectly legal optimization, it will be more difficult to get it in. But with -O verifiable, I think that's.
Shouldn't it be orthogonal?
should be able to ask for this mode.
You should be able to ask for this mode, whether you're compiling for O2 or O3. It sounds like if you do it like that, like O verifiable, then that overrides whatever O2 or O3. It's a specific mode.
It will be like a modifier.
Okay.
I get, yeah.
So normally it will be like an F flag.
Yeah. It could even be a collection of F flags. So
Right.
you can
So
say like,
because when you do -OG, that means it's that specific optimization mode.
Okay, so it will not be like minus O small and fast from the context.
Right.
That's definitely our question. Like if it's separate flag, then like one toggle, like O1, O2, O3, O verifiable, and not only that, it doesn't
Minus
have,
F.
then maybe it makes sense to do its own like passes.
Minus F verifiable would be
Yeah.
minus F. Okay.
And
that's a good point.
if you can get away with just disabling certain passes, you don't need to do anything. I mean, you can just put the passes you want to disable into not a file, add it as a dash at opt name of the list of the passes you want to disable, and there you go. And you can maintain that separately. It doesn't have to do anything with GCC.
Desire to not have that when you're targeting BPF.
I think the problem is you want to do passes.
It
that-
could be. It could. Sorry. It could be because there could. I mean, some people are starting talking about using BPF in contexts where the verification is not gonna, including GCC itself.
Also, I think in general, a lot of the time it's not an entire optimization pass that's problematic. It's a specific transformation done within that pass.
That's why you need the flag.
But the goal is to get verifiable code.
Yeah.
So if you just disable these optimization passes in order to get verifiable code, you'll be happy.
Yeah, but you end up with just like -O0, right?
No, because because also there is a limit of instructions that a BPF program can have. So if you compile optimize,
Cannot really work with dash 0 because with dash 0 there's like so much stuff that's generated.
You actually need
And
it.
stack usage
Yeah,
is
so
really
on that end, if so O verifiable says these are the sort of things I'm going to certify for verification, but what are those things, right? That's also the problem with O verifiable. This is a moving target. So fundamentally this doesn't solve the problem still.
I mean, it alleviates the problem.
It alleviates the problem.
Hopefully down to practical levels, right?
It's just trying to be like practical for what like people use today.
The problem is not solvable.
Yeah.
In
In general, yeah.
It's just like internal, like verifier is trying to determine what the program terminates. Yeah, and be hard, but well, we still do it. So be in practice.
Well, in a very crude way, we just give up at some point and say, rewrite your program.
So yeah, but I think it's important to. I mean, we put the option in place, even if it's a no, or with one. Like, and then we will need to agree with this with the global maintenance and everything, but we put the flag in place, and then we start actually maybe sending patches to the different passes to adapt their behavior according to the flag, and maybe it may work.
But as Indy mentioned, don't you need to include the version of the verifier that you're targeting? Because if you have better verifiers that can do more things, you don't want to turn on.
In fact, yeah, that's an open question too. Indeed. Yeah.
I think the technical mechanism is just going to be an F flag and then a target hook for some of it, and the rest of it will be you can mark certain pattern matches with another flag. We already do that for fast math and things. I think another interesting example maybe is how we handle certain targets where I think 0 is a valid pointer. So AVR, I think they disable the null pointer check optimizations. And the other thing that I've forgotten about. Oh, sorry, no, that's what I was going to say. I think, which is what Nick was saying, we could start with disabling everything and then just have passes that we certify. Is probably, but the problem is, yeah, of course, some of those passes that we certify will have stuff that we have to sort of hack out. It's fine until it isn't. But that's the thing, isn't it? That is always going to be like that.
Actually, you can, Like we have internally, we have a plugin that we use it to find bugs, which optimization pass is responsible for a bug that it permutates all the optimization passes, right? Maybe something similar could be done, but disabling entire passes, you have the experience in LLVM. Is that a viable solution?
I don't actually think we tried it. Like disabling entire passes, like picking the passes we want to, like it's the last option here, like building the complete like optimization pipeline from scratch. If something like works, like from the general like library of the optimizations, we can pick that pass. If it doesn't, like we rewrite something on our own. We didn't actually try it. It's like a big undertaking. But honestly, I personally think that given this number of workarounds, it's the only thing which will work in the end. Like, but
Sorry, very, very theoretical, but doesn't it look like this is the sort of case where the verifier needs help, right? So shouldn't the line of thinking be in the direction that let's emit more things so the verifier has an easier life?
Sorry.
Not really. Like, it cannot trust annotations.
Yeah. Cannot trust annotations.
Because it's like it's safety, right? Like, compiler tells me, yeah, I did correct job. It's kernel, right?
Okay.
Like it can only understand assembly.
Yeah, okay.
And based on the safety decision, based on assembly. And things that come with the kernel, like VM payment BTF comes with the kernel. So it trusts the kernel build process, trusts that GCC didn't screw up, that linker didn't screw up, that the whole didn't screw up.
Okay, yeah.
And that information is correct. But annotations that come from user space, use programs, not to be trusted.
Just like you can't trust us.
Yeah, okay.
Okay, so let's see if we can go through the particular questions that you have there. So the second one, backend specific checks inside optimization themselves, that's a no.
No,
So
that can be done. That can be done with close target.
yeah, but
Like I said, that's done for null pointer checks, I think.
well, yeah, but that's a different thing. That's like an architectural feature.
Well, you could say it's
And it's not moving. It's not moving.
Okay.
Like, you know, I mean, you, okay.
Yeah, you're going to constantly subsume more. Yeah.
Yeah, well,
But then you get to the thing of why bother, then. You know, you do have to be practical for certain cases.
So that's why if you go through a global flag, even though it could be even backend specific or not necessarily, I think will be easier. And
global flag that not backend specific is actually cleaner because you
right.
can test it on like x86 and everywhere else.
Yes. I agree, yeah.
It's probably useful for debugging as well.
Maybe, and also some idea I had at some point is that I think that more and more some companies are relying on using static analyzers on compiled code, and maybe.
Wait, another part that I noticed, I forgot to mention here. Some of the stuff that compilers are forced to do when it's compiling code to prevent speculation, because like if there was a law hoisted, it would trigger, it would open the door for speculative.
And that's maybe one of the things they want or hope to catch with the static analysis of the compiled code. So maybe if you compile verifiable or code on the BPF in the BPF sense, maybe it will also be more verifiable in the other sense.
Normal x86, like on x86, the kernel is now full of this compiler styles, spectrum one.
Yeah.
Because
To avoid
they
the
actually like, prevent the hoisting and this like unnecessary law that will break the whole stuff.
Isn't this all a false target? I mean, because you can produce verifiable code verified and all looks good, and then you produce production code where you don't have the -o verifiable, and suddenly it's not working, and you don't know why. There's no point in verifying code you're not going to use. Okay, so you're going to do production code with less optimization than you could have done.
Yes.
And you can complain that it's too big and too slow.
I think also there is more than one verifier. There is more than one verifier, which is an additional problem that we will need to deal with on the GCC side.
Yeah.
Okay, but I mean, when people come back and say, why is this so big and so slow? And you say, well, it's all the verifier's fault. We had to compile for that.
Well, but the BPF program, have you reached the stage there that it's a big condition?
It's already a problem, let's say, for ARM64 with using only half of the registers that are available on CPU. So the code already is poorly optimized for ARM. It's a problem. We have like, well, 10 different ideas how to fix it.
Just trying to see if it actually makes sense to this, what I'm thinking. So instead of trying to disable optimizations, wouldn't it be possible to actually enumerate a list of rules that the verifier requires, and then use it as a pass in the end of the flow of GCC to actually fulfill the requirements for that to be true and verifiable?
But how, like, if let's say, like, going back to, like, Edward's, like, first transformation, just hoisting the pointer computation. Okay, let's say you do another pass in GC and you say that, oh yeah, here, Edward, can you scroll back to the very first example? This one. Yeah, so let's say, yeah, you have this ASIN code on the right, you do this pass and your pass says, oh yeah, this is screwed, like, verifier will not be able to understand it, what you gonna do?
You emit a compile table.
Yeah, but
there's no.
just as bad as like
Just a question. There is no condition that you can add that you in the verifier will guarantee you that whatever is inside there is actually valid. Just if you bound the code with some condition. So I don't know this example. To be honest, like I fail to understand what's the problem. But if you bound that code with some condition, that will guarantee.
No, this is the code that bounds it. Like it's,
okay.
That's what it is. It's just a compiler voice and the address computation.
Look, so the problem, like the original program, like you have some variable of in a register.
Okay.
Then you have a comparison, like jump instruction. And verifier tracks it that in the true branch of this jump instruction, the value of this register would be less than 42. Then it sees an addition to a pointer, and it knows that like I have some range for the pointer, I have plus like from 0 to 42 to it, and I know the new range for this pointer. And therefore, if I know that this is like a valid range for this memory region, I can allow this access.
Okay, so that is valid, the one on the left, right?
Yeah, this is verifiable. And on this side,
this is not verifiable.
We don't know the boundary for.
Pointer global or not?
It's a local variable. A local variable. So you have this off, and at this point in the verification, it's unbound. It is unbound. Like you don't know the range for it. Then you add it to the pointer, and like in this other register where you have the pointer, it has an unbounded range. So, and then you have a check for the original register which contained offset. But the verifier is silly. It cannot propagate this value back to the pointer. It already lost information that PTR and
but
BoF
what
are
I'm
connected.
saying is that you'll have a pass in GCC or whatever compiler that contains a list of rules that the verifier requires to validate code as valid, and then based on those rules, you infer that this condition needs actually to be moved up.
Isn't this more on, I look at this, I'm not a compiler guy, but it seems to me that can the IR be extended with semantics that express that you cannot hoist in terms of like dependencies here that for BPF will have some kind of meaning and for other.
Yeah, but then you will need to make the passes aware of that, of those RTL nodes, for example, or whatever.
Is that what your verifier mode would do? Because you said it would be disabling optimizations, and I'm saying like the IR has semantics that express what is special for BPF, some special IR nodes or whatever.
Well, that would be another way to.
And then for most architectures, that node is like an op.
I don't know. I mean, if you keep in the RTL or the AR,
but
if you keep the state of which pointers can be hoisted or whatever,
right,
then you can keep the state and check the state after.
Right, but the point is that it's framing this in terms of semantics in the IR or in RTL or whatever, right, in terms of let's disable this optimization because it does bad things.
Yeah, but the problem remains that there are two things. One thing is if you detect that something that some pass has made the code not verifiable, so to say. The only thing you can do, unless you undo, which is something else that you have done, right, at some point in an LVM, either you undo or you emit an error, which is useful, but not...
That's like linked. You're talking about undoing, and I'm talking about expressing in the IR semantics when the front end parse the thing, so that the optimization knows, okay, I cannot apply this optimization because...
So this is what we did in this case. We detected earlier that there is this IR and insert this red thingy that goes through the back end, through the middle end, through all the optimizer, stays there, and well, this hoisting does not happen.
But I think this is different because for that case, you're pattern matching it quite late, aren't you? As opposed to...
This is applied early,
okay.
just before like all the optimizations. So in a sense, yes, it makes sense, and that's what we do, but like in some like ad hoc way.
And this brings us to, I asked Christopher to please come to the session because he's the author of this SMT GCC plugin that basically, correct me if I misunderstood, because, so basically this plugin is a translation validator for GCC. So it's used to see if GCC is broken. And it does that by, is it Gimple passes only or also RTL?
It's Gimple passes, but it can also compare the assembly for RISC-V and AR64. So see that's, so in some sense, what I implemented, well, let me express it from the other side. The verifier tried to see that everything okay, and it does it by approximating the analysis. I have implemented a perfect verifier, although it can time out if too complicated code. So that's the difference between them. So that is, it does solve a slightly different problem than what you want. But I want to comment on this discussion about this example. So can you go back to the slide where that one, yeah. So this hoisting is actually not semantically correct on Gimple either if, well, that depends on if this can overflow or not. So semantically, GCC has decided that those values where this is undefined cannot happen. So therefore it hoists them. And the problem here is that the verifier is too primitive to see that. So my tool will also say that this is perfectly fine because these cases where it overflow cannot happen. Because my tool verifies that you never read out of bounds. And that is what the verifier tried to do here.
Oh, just for context, the tool that he wrote, it checks that when an optimization pass is executed, the output of the IR resulting from the optimization is still semantically correct.
Yeah, LVM has equivalents like
yeah, LVM has the same thing. Yeah.
So for LVM it's alive 2. So I have sort of implemented the equivalent of alive 2 for Gimple.
So that's why I was curious to see if somehow your infrastructure in SMT-GCC, which is a plugin, meaning that eventually maybe each BPF implementation could provide its own plugin with its own verifier, adapted to its own verifier, if somehow we could use SMT-GCC as an infrastructure where to actually build something.
Right. So it's also a different problem, because let's say you have written a function doing whatever, and you have a bug in your backend, so it always returns 0. Always return 0 will pass the verifier, but it will calculate something else than what the author of the function thought. My tool will verify that what your backend does the same thing as the original source code. Right. So it will find bugs in the backend where you generate the wrong instructions. But since the verifier problems is that the verifier does simplifications in its analysis. So if I can model those simplifications, then I can check them. On the other hand, I think how to model it is more like pattern matching. So then it's much cheaper doing that as a normal compilation pass rather than in my infrastructure.
Okay. You plan to support the BPF backend?
It's high on my list, to-do list, and it should be pretty simple, because when I add a new architecture, when I add ARM, for example, to get the standard instructions, add multiplication, branches, whatever, it took 3 days or something. And then I spent several months on doing all the horrible vector instructions.
You support these 5?
Same there, yeah. So I support vector support for both architectures. Again, there are lots of limitations in my tool, but it worked. For example, I compiled a Linux kernel with it last week. It skips most of the functions that are not supported for analysis, but it found a bug in GCC anyway, in the functions it could analyze and so on. So that kind of tool has its uses, but it probably does not solve your problem.
Okay. Well, thank you anyway for. So.
Sounds interesting to explore.
Yeah.
Is it all public somewhere?
GitHub.
Yeah. Well, I can send you. I will send you all the notes. And
also, I'm going to talk about formalizing Gimple on Sunday. So there I will also shortly present my tool. But even though I'm talking mostly about the work of formalizing what the Gimple actually is doing.
That they will love to see.
The short version is that it's unsound.
Gimple was introduced, what, 2000, 2001? Like 25 years ago, yeah.
2005-ish, I think.
So
yeah.
Yeah, and it's evolved daily. Right.
Okay. So,
Just one other thing. The other thing I find quite distasteful with this idea is that if you implement it, the developers of the verifier can have less pressure on them to actually improve it. Why fix problems they verify? Why don't we just tell the compiler not to generate that type of code?
Yeah.
I don't think that's good.
Well, I don't know. I mean, what's the verifier used for? Not to prove a point, right? Is to make it possible to run BPF programs in the kernel. So that's a net benefit. I mean, is there anything like fundamentally wrong with that? In the sense is, what I mean is that...
But it takes pressure off the verifier developers if
right.
they don't have to.
I understand, but I think the pressure should be shared. Okay. Like, not all the pressure should be on them, like make a perfect verifier so you should support any semantically correct program. But on the other side, all the pressure cannot be on us, on mutilate your compiler beyond any recognition, so we can actually run the BPF programs. There has to be some sort of middle ground here, and I think that's what we are looking for, right? Yeah.
So I think Nick makes a very good point. That's why I really think that in the end stage, we should be actually using a verifier or running a verifier. And then to be pragmatic about it, if you imagine that you are coding, you code and you verify that something happened that turns the code unverifiable, and imagine that you could actually change the assembly in order to make it verifiable, like a condition just like what you have there. And that's the kind of approach I was talking about. Instead of trying to avoid optimizations in the middle end or in the back end that would actually break the code and turn it unverifiable, is to add whatever the compiler knows about the structures and the sizes and the offsets to the final stage of compilation in order to make it verifiable. So you run the verifier, check whatever is happening, and the compiler itself would actually add the code in order to make it verifiable.
Code or metadata?
No, code.
Like completely undoing the transformations done on the optimizer process, I think it's impossible. Only things you can possibly do, but you need like a full-fledged verifier in the compiler for this, is insert some assertions.
Besides, you need a limit.
Well, yeah, but sorry, on the other side, with profile guide optimization, that's what happens.
Assertions are fine.
So this will be, instead profile guide optimization, will be verifier guide optimization.
We don't have concept of assertions in the kernel right now. If BPF program runs, it runs. It cannot assert and stop.
But in that code, you actually only move a if condition before. You can actually have two if conditions. You can have another if condition there in the backend.
Oh, you mean you run the thing
run the
at the start, you verify that the program is fine, and then you run it in the end and insert like checks it?
Not even you don't need to run it in the beginning. You run it at the final stage of compilation before you emit assembly. You run the verifier that runs on RTL, and if it fails, you would analyze what failed and add the required code in order to make it verifiable. Like assertion is what you say.
That's the hard part. What to do with
Yeah, if it's not verifiable, then you end up not having verifiable code. No, hold on. You can only verify if you actually realize that the structure size is valid and everything is valid.
How do you know why it's not verifiable? You need to
Like,
so in that
like for example, like
in that particular
Right, that's the problem. One thing is talking in abstract as verifiable, but let's go to some particular example, right?
Here's an example. So this one is, we talked about hoisting condition in the market. If you go to the one that assumes a pure function.
Which one?
Forward, it's a switch statement.
Just one.
Yeah. So that one, how would you undo that? You'd need to go back and you'd need to know whether or not the function was pure or whether we discovered it was pure.
Yeah. For this one, we introduced a special attribute for the type.
Yeah.
Because that's the only way. Like here is no pattern to match. Like we have to say early at the C level that this is like a special structure. Don't mess with the offsets.
Yeah, undoing that would be very challenging.
How you will do this?
So, but going back to the original example, sorry.
But this is an example.
So, why would you in your code actually do that verification? You didn't need to. The compiler could add it in if you had a verifier.
No.
The offset would be below 42, right?
Huh?
Maybe the compiler could actually verify that the offset should be lower than 42 because of the size of the structure or something.
If you're doing an access to the pointer inside that if, then it's statically guaranteed. Because the semantics of the program offsets less than 42.
Yeah, but I mean, you don't need to actually do it explicitly. Having that condition could be the result of running the verifier and verifying that, okay, I cannot verify this code. And then for that, I need to actually add this condition, and it would be added automatically by the compiler. Would it?
Like, there is one more dimension to it. Like, for example, there is a concept named like core, and basically you can write down C type, and it will be like not a physical C type. You put a special annotation that this is not a physical C type. Then, like all accesses to variables of this type are annotated with relocations in the final binary, and the BPF program loader changes the offsets at load time of the program. It checks like this particular type, which offsets are for these fields, or what is the size of the structure on this kernel, particularly currently running kernel, and it adjusts the program. So it might be not known to the compiler, like the range of the PTR when the program is compiled.
But would it be known by the compiler that you actually need to verify that?
No.
No?
This load time is like
for the specific kernel. The program adjusts itself to the running kernel.
So one more. We don't have the verifier as a library. If we did, then part of this problem wouldn't exist because then we'd have a strict version for it and everything. All of this assumes being able to run it and evaluate it, which is a big if. Supposing that it did, you have the issue of core. But you also have the issue of different architectures where the verifier may not behave the same necessarily, or different versions. Like even if we're able to do this, what if we're testing against a newer version of the verifier and then it turns out the user isn't? I just don't think it's a feasible position to be in. But it doesn't matter anyway, because in order to have a verifier that we could run in the compiler, we would need it to be codified and runnable standalone, and that doesn't exist. And it would be a very big project to get there, I think. And we would have other problems solved if we had that. We could have a much easier test suite, for example. So I think it relies on a lot of foundations that we don't have. I just don't think we're close to that at the moment.
Like codifying what verifier does is hard because there are multiple verifiers.
Yeah.
One in the kernel works completely differently. Is this symbolic execution style? It's completely different from the preval verifier that Microsoft is using. That one is SMT solid.
So do the alternative verifiers do better with these patterns? Like
sometimes yes, a lot of time worse.
Worse.
What I would like to really avoid is that, I mean, if we start implementing what you guys have been implementing in LLVM, and then we follow the same path, very likely we will end at the same point.
Yeah, that's the time to not repeat the same thing.
Right. So, yeah. But something has to be done.
If you had fine-grained control over what individual optimization passes do, so you had, let's say, command and option for every single sub-optimization, you could then selectively enable and disable based on which verifier you're targeting.
But that again requires codifying what the verifier does.
No, yeah, but that could be done totally separately. You could have a file that lists all the optimizations to disable for verifier foo version X. And just pass them, you pass them on the command line when you're building. You can maintain that per verifier, and you wouldn't if you wouldn't have to change GCC once you have the fine-grained control over the optimizations.
Assuming you could assign a version of the verifier.
Well, yeah.
But that's a great place to start, right?
Yeah.
It probably is.
And then you don't need -o verify. You just give it the list of known things to turn off for that verifier.
Yeah, I think having sort of some metadata on the side that you can have BPF to or whatever pass into GCC with some flag as a list. That's probably better than nothing.
As long, yeah.
It's quite easy to implement.
It will be difficult to not over-engineer, though.
But remember as well that for sanitizers, this infrastructure already exists. So for sanitizers, you can already have suppressions that take function names and the particular sanitizer that they suppress. It's kind of the same thing, it's a concept. So at least we'd have something that we're following.
It's the same kind of arbitrary restriction.
Yeah.
Could be a way to...
It's a start anyway, because like I said, you can maintain it, or what Nick said, you can maintain it on the side, it can be updated independently with GCC. You can have BPF tool pass it in as a flag every time.
So we would like to make this BPF specific since the beginning, or target independent since the beginning?
Yeah, you said you wanted some level of target independence, or was that just because of an LLVM?
I would say that target independent.
Independent, yeah.
Is there a reason?
Yeah, I'm not against it, but what's the, or is it just because you foresee a BPF-like thing in future and you don't want to duplicate the work, or what's the?
Well,
what do you have in mind?
To me, I think, in my opinion, it would be easier to to convince a middle maintainer or a GCC maintainer to add some flag based on some generic flag which is independent from backend that by a backend hook, that getting a new backend hook there, I think, but could be wrong.
But target hooks get away with a lot more.
Yeah, but I mean, every target hook that you see that some mischief is around.
Yeah, very
You would
naughty.
also have to add a whole bunch of target hooks just to only implement them in BPF.
So
ADR does that.
If you can come with something generic enough that it's not that to touch some particular event, the better. And who knows, maybe we will have some other verified targets in the future.
Well, I think someone's playing with a WebAssembly backend. I mean, it's different, but it's similar in the same sort of very restrictive, unusual environment.
Yeah. All right. So what we can do is that we can start maybe a wiki page in the GCC wiki. This will need one because if it's independent from the BPF backend, then it's something which is in principle orthogonal to it, like verifiable or something. And but then let's work together because we know GCC, but you are the ones who actually have all the experience about the history that should not be repeated. Huh?
And all the sample code that you...
And all the sample code and everything. So yeah, I don't know what else we can do.
We can start putting together lists of optimization options that don't seem to break the verifiability on current kernel version or the last few.
Right. So yeah, I have a more generic question for you, but I don't know if we. Which is the question is, other than the BTF tags, that's okay. Is there anything else that would be required for GCC to starting like consider like one of the primary BPF compilers, if not the only one,
Probably passing the self-test.
Other than
That's a good milepost, yeah.
I would say as soon as the self-test are passing, and let's say majority will pass, like missing may go to. It's not a big deal, especially implementing it. Come on, it's like a couple of days.
yeah, it's just an assembler.
Yeah, just a single instruction. But
it's an op with a new
table
name.
tags is a big deal, and once they're there, all the self-tests will be there. Once all tests are passing, and like because you don't implement the same thread go to that just to land it like what it would be go to, well, yeah, that's absolutely fine. Some of the tests will fail. That's okay.
There is no kernel support for this indirect jump for now.
So that's like previous
The patch set is still in review.
Yeah. Okay. Well, we have to talk at some point about this CFG information that you need for. What it was it for again?
The indirect jumps thing, or
the indirect jumps.
Yeah, that's separate discussion. Yeah, that's like we can decide which way.
Okay. Good. So.
Yeah, but those are these big things. Like we can see that there are enough of benchmarks even now. So, once the self-test are passing, I would say this is like a bar, like because until decal tags are there is nothing to benchmark. But once decal tags are there, majority of self-test are passing, we can start benchmarking. And then now we can say, oh, Quark optimized curves versus GC optimized curve. And people do care about performance quite a bit. Like this whole thing, why the packet access is there? Well, it's packet access. This is what parsing packets, terabytes, 30% of the internet. Not kidding.
I mean, yeah, that's why we don't want to run with O0, because this program can run on each packet arriving on the network interface. So, like, we want it to be reasonably optimized. Like
30% of internet processed by this program, so we care about performance.
Yeah.
They were there because they're way faster than anything else.
Okay. Oh, speaking about self-tests, what about this? We are a little bit concerned about what was this? It was the vmlinux.h. It was the clang.
preserve access index attribute attached to all structures in the.
Yeah, that's not.
Right. So we need to get that figured out.
I thought we already agreed on task forward.
Yeah. You actually you made those BTF tags for.
There was a pretty sure it was I forgot because it was.
I'm mentioning this because this has been a problem for SCEDEX, and this has been a problem for what is this that Alan Maguire maintains? BPF Tune.
Yeah.
BPF Tune because they want to run with GCC, but then they need a patch BPM Linux.h or a patch BPF tool that generates a header that actually. Okay.
But I thought that it asked forward, right? So we just didn't want to learn the hack. And solution was discussed. And let's just code it. Small matter of programming.
Well, yeah, but you code it. Well, okay.
See, like, we coded.
We provided. Actually, I sent a patch with a perfectly correct solution that was not a workaround. You did not like it, but it's fine. Then you do what you want.
Okay, we will take care of that thing. It can be landed.
Okay.
At some point.
So thank you, and we can work on this, and not just blah blah. We really have to get on with this because now we've reached the point in the port where this has to be addressed. And then there is this thing about generalized core, which is a melon that I don't know if we want to open at all. You are not the first one suggesting to do that, by the way, you should know. Cupertino also. What? Yeah, we should wrap up. Yeah. But we can do it hallway and... or in Sunday, if we can find a slot with a room with nothing in it, we can, right? Okay, well, thank you, everyone, and thank you for the BPF people for coming here.